Hello. Today we'll be doing the number 4 on the Math Calculus AB FRQ. This is on the non-calculator section. So we'll start by reading the question. An ice sculpture melts in such a way that it can be modeled as a cone that maintains a conical shape as it decreases in sizes. The radius of the base of the cone is given by a twice differentiable function r, where r of t is measured in centimeters and t is measured in days. The table above gives selected values of the first derivative of rt, the rate of change of the radius, over the time 0, t in between 0 and 12. So A, first we have to approximate the second derivative of r using the average rate of the first derivative of r over the interval 7 through 10. Show what you do to use that and indicate unit measure. Okay, so first, since we had the first derivative of r, and we know that r is derivative and therefore continuous, we can use MVT to solve for this. And MVT is just f of b minus fa over b minus a. And since we're solving for it over the 8.5, and we're only given 7 to 10, obviously we'll use the values of 7 to 10, and those will be our b minus a values. And if we put it in, so we plug in the values, so t will be our b minus a, as those are our constants, like since r over t will be f over b. So f of b at 10 is negative 3.8 minus negative 4.4, as that is the value at 7, and then it's over 10 minus 7, and then you'll get negative 3.8 plus 4.4, which is 0.6 over 3, which is equal to 0.2. And then it asks you to indicate the unit of measure, which is centimeters per day squared, because it's not asking for the prime, because if it's centimeters per day, then if it's a second derivative of that, it's centimeters per day squared. So you could just put it like this. And an easy way to think about it is like velocity and acceleration. Okay, so then this is our answer. Now, that's A. Now let's move on to B. So in B asks, is there a time in between 0 to t in between 0 and 3 where the derivative of t is equal to negative 6, and to justify your answer. So for this, we can use IVT, also known as intermediate value theorem. We can use IVT since r over t is differentiable and therefore continuous, which allows us to use it. So using IVT, we know that, so since it asks for 0 and 3, we know that that r prime 0 is equal to negative 6.1, and r prime 3 is equal to negative 5.0. So therefore, that it means that between these values, negative 6.1 and negative 5, that if it's asking if there's a value in between 0 and 3 where it can be negative 6. So IVT states that if it's continuous and differentiable, that in between these values there has to be a value that's at negative, like in between 0 and 3 there has to be a value at negative 6, because negative 6 is in between negative 6.0 and negative 5.0. And since negative 6 this is true, because IVT proves that in between 0 and 3, which is what the function is in between, that means negative 6, it is possible. So this is yes, and I justified my reasoning, so we won't write that. Because, so to conclude, it's just basically because IVT proves that if its function is continuous and differentiable, which it is, therefore there has to be something so there must be like a c that exists between a and b. In this case, c is negative 6, in between negative 6.1 and negative 5, because negative 6 is in between those two numbers. So if to get from negative 6.1 to negative 5, it has to be at negative 6 at one point, which is pretty much all I'm trying to say. Okay, so then let's move on to C. Let me erase this real quick. C. And so C is asking to use a right Riemann sum with 4 subintervals to indicate the table to approximate value of 0 to 12 R over T. So we're already given the values, so we just have to make sure that when we create a right Riemann sum that we use the values on the right. So what I would do is just start on the right and keep moving left. So basically all we have to do, so this is pretty easy, just make sure not to make any silly mistakes. So 0 to 12, so the entire function R prime or T equals, okay, so make sure you start from so basically you just have to find the difference of T and then the value of the bigger value. So for example, the first one would be 12 minus 10, which is 2, and then the value of R prime T at 12, which is negative 3.5. And you just keep doing, and then you add it, and then the value of 10 and 7, which is 3, and the value of at 10, negative 3.8, and just keep going, and then it's 4, because the difference between 7 and 3 is 4, and then the value at 7, which is negative 4.4. And then you do your final one, which is 3 and 0, which the value would be 3. Make sure this looks like a plus. 3, and the value at 3, which is negative 5. And then you equal that, and if you put that into a calculator, if you did it right, you should get, well, you don't even have to put in the calculator, to be honest. So all you could just write this, and then put it in centimeters. As that would be, as for the AP exam, you do not need to you do not need to simplify. So this would be your answer. You don't put this equal sign. Cross it out, centimeters. Okay. So now D. The height of a cone decreases at a rate of 2 centimeters per day. At time t equals 3, the radius is 100 centimeters and the height is 50 centimeters. Find the rate of change of the volume of the cone with respect to time in cubic centimeters per day at time t equals 3 days. The volume V of a cone with radius r and height is V equals 1/3 pi r squared h. So this question does appear challenging. However, related rates really aren't that difficult if you really think about it. So first, what I would do is just put all our constants. So we know that V is equal to 1/3. Since we're finding the derivative of V, so we know that V is equal to 1/3 pi r squared h. And we're trying to find dV over dt. So if we take the derivative of V from here to find this, we can just put, so pi and r are constants, so we put 2 into the 1/3, so it'd be 2/3 pi r, because then you would subtract 1 from r when you're taking a derivative. And since you take the derivative of r, it'd be dr over dt, because that will be a value. So in a case where you're taking the derivative of something that will be a value, you just put dr over dt, like for r, and then you take the derivative, and then it'd be times h, and then you do plus r squared over h, r squared dh over dt. The reason you do this is because it's you have to use chain rule, and then so basically what we did is, this is one, so it's product rule, right? So use FGI plus GFI. So think of this as one value. So this will be F and this will be H. So you have F, so we already have F, and then G prime is just dr dh over dt, and then plus H plus F prime, which is right here. So I just kind of split it. I just kind of did the order in reverse, but it's pretty much just product rule, and then you have dV over dt there. Then you just use all the constants that you already have. So all we need to find, so we're looking for dV over dt, and we know what pi is equal to, like in a calculator. So r is, if we look at it, r is equal to 100. dr over dt is equal to so then dr over dt is equal to, find the rate of change of the bar. Hang on. Two-thirds. The height of the cone is equal to the height of the cone decreases at a rate. The radius is 100 centimeters in the height. Okay, so as we know the time. Okay, so then height would equal to 50, and t. And then the dr over dt would be equal to -5, and so the reason derivative of r, and we know dh over dt is 2, because it decreases at a rate of 2. Okay, so the reason that dr over dt is equal to -5 is because if you plug it into the original equation of, if you just put it to solve dr over dt, the radius, and you put the other values, it'll be equal to -5. Like, for example, so if we use the formula of radius equaling to 100, and we know the height, we can find the volume of the initial, which will help us find the derivative of r, which is how we know that the derivative of r over dt is equal to -5. Okay, so then you just plug in the values. R is 100. dr over dt is -5. H is 50 plus 100 squared, because r squared, -2. And if we solve for this, you'll get -70,000 pi over 3 centimeters cubed, because it's volume per day, and that will be d. So that is how you solve it. That's how you solve the question. And that's pretty much, that's how you solve D, and that's how you solve number 4. So that's how you do number 4 on the FRQ non-calculator section. Thank you.
Hello everybody, and today we're going to be going over the 2022 question 6 FRQ for the AP non-calculator section exam. And this question is based off of the understanding of PVA, which is position, velocity, and acceleration. And what the question does give us is two particles, particle P and Q. And for particle P, we do know the position of the equation. We know the equation for its position at time t. While particle Q, we do know its velocity, and we do know its position. We do know its position at 1 second within the time. So the first thing it asks us for is, what is the velocity of particle P at time t? And we're given the position of particle P at time t with 6 minus 4e to the negative t power. And to solve this equation is pretty simple. Is we just have to find the derivative of the specific equation, which would just allow us to get to velocity. And when we're finding the derivative of this equation, we know that 6 is a constant, so all we have to do is find the derivative of 4e negative t, which would be 4e to the negative t power So that would give us, that is the derivative, and that would be the equation for the velocity for this first section. And part B is asking us what is the acceleration, and if we can determine if the speed is decreasing, and we have to justify the answer for this. So let's start off with the acceleration, and what we do know about acceleration is that to find it we have to find the derivative of the velocity, and for particle q we are given its velocity, so this would be very simple in just finding the derivative of 1 over t squared, and we can also interpret 1 over t squared as t to the negative second power, and if we just do the derivative like that, we do gain negative 2t times to the negative third power, or also negative 2 over t to the t cubed, and that would be the equation for acceleration. And when we're finding the speed, we have to compare, we have to see if that the speed and the acceleration do have opposite signs, because this would indicate that the speed for particle q is decreasing, but we have to use a number greater than 0. So I decided to use 1 because it's a very simple number and allows us to get the equation faster. So for velocity, if we do plug in 1 to this equation, we end up with 1. Well, for the acceleration, if we plug in 1 to this equation, we end up with negative 2. What we do come to an understanding of is that 1 and negative 2 have opposite signs. That means the particle speed is decreasing because the speed is going one way while it's accelerating another, so that just means it's slowing down, and this results in the speed decreasing. So the next part of the question, it's going to be asking us what is the position of particle q. We're given its, for this equation we're given its velocity of particle q, and we're giving the position at a certain time, which is at 1 second. We know that the position would be 2. So what we do have to find is the antiderivative, but the antiderivative is a little bit more complicated than that because we don't know what the constant is, because there could be a constant and we have to figure that out, but that is what this equation here is for. So when we first take the antiderivative of 1 to the t squared, we also know that it is t to the negative second power, and this would lead us up with t to the negative first power as the equation, and this would mean that the position for particle q, we would get negative 1 over t plus c, and the next part of the equation is to find out what c is, and we know that at second 1 it equals to 2, so we set the equation equal to 2 and we plug in t as 1, and we do get is t equals negative 1 over 1 plus c, which would also mean that c would equal 3. So the whole equation we're going to come back to is we're going to plug in c for this 3 for c right here, and we would say that the position for particle q is negative 1 over t plus 3. This would help us determine where specifically the particle is at each second. So the last part of the equation is going to be asking us for which particle would be farther away from the origin during the limit infinity. So what we have to do is we have to set both velocity equations, position equations. We gain the position for particle q in c, and we gain the position for particle p, it is given here. So I decided to plug it into 1 to see which would be greater during infinity, and what we did get was that x's limit would be 6. It would be equal to 6, while y would be equal to 3. And we also know that particle q is slowing down because of the answer we did in B, and we figured out that the speed is decreasing. So based on that information, we can determine that particle p is going to be farther away within infinity time. Thank you guys for listening to the FRQ section, and that is it.